Hi everyone, this is Arvahita, Assistant Professor of Computer Science Engineering Department from Rohini College of Engineering and Technology. I am here to explain a concept about cloud computing. Let's see about virtualization. Virtualization is a technique which allows sharing single physical instance of an application or resource among the multiple organizations or tenants. That is, the tenants may be the customers. Virtualization is a proved technology that makes it possible to run multiple operating systems and applications on the same server at the same time. Virtualization is the process of creating a logical, that is, the virtual version of a server, operating system, a storage device, or network services. The technology that works behind the virtualization is known as a virtual machine or a virtual monitor, that is VM, or virtual manager, which separates the compute environments from the actual physical infrastructure. Virtualization is shortly called as the abstraction of computer resources. Virtualization hides the physical characteristics of computing resources from their users, applications, or end users. This includes making a single physical resource, which may be a server, an operating system, an application, or the storage device. It appears to function as multiple virtual resources. It can also include making multiple physical resources, such as storage devices or servers, appear as a single virtual resource. In computing, the virtualization refers to the act of creating a virtual version of something that, like computer hardware platforms, operating systems, storage devices, and computer network resources. The creation of virtual machine or over the existing operating system and hardware includes the host machine, guest machine, hypervisor. So host machine is the machine on which the virtual machine is created. Guest machine is the virtual machines referred as a guest machine. Hypervisor is a firmware or low-level program that acts as a virtual machine manager. So this is a diagram which represents before virtualization and after virtualization, how your resources are split. So first, the software is tied to the hardware, single OS image per machine, one application workload per OS, and inflexible and cost infrastructure, which is shown in before virtualization. And coming to after virtualization, it is multiple workloads per machine, software independent of hardware, system data, apps, or files. Now let us see about the advantages of virtualization. Reduce cost, efficient hardware utilization. Virtualization leads to better resource utilization and increased performance. Testing for software development, increase availability, save energy. The disadvantages of virtualization are extra cost, software licensing. Now let us see about the implementation levels of virtualization. Virtualization is a computer architecture technology by which multiple virtual machines are multiplexed in the same hardware machine. The purpose of a virtual machine is to enhance resource sharing by many users and improve computer performance in terms of resource utilization and application flexibility. The hardware resources such as CPU, memory, I/O devices, etc., or software resources which may be operating system and other software libraries, they all can be virtualized in various functional layers. The idea is to separate the hardware from the software to yield better system efficiency. For example, the computer users gained access to much enlarged memory space when the concept of virtual memory was introduced. Similarly, the virtualization techniques can be applied to enhance the use of compute engines, networks, and storage. This virtualization layer is known as hypervisor or virtual machine monitor, that is VMM. The VMs are where the applications run with their own guest OS over the virtualized CPU, memory, and I/O resources. The main function of the software layer for virtualization is to virtualize the physical hardware of the host machine into virtual resources to be used by the virtual machines exclusively. The virtualization software creates abstraction of virtual machines by interposing a virtualization layer at various levels of a computer system. The common virtualization layers include the instruction set level, architecture level, that is ISA, hardware level, operating system level, library support level, and application level. Now let us see about instruction set architecture level. At the instruction set architecture level, the virtualization is performed by emulating a given ISA by the ISA of host machine. For example, the MIPS binary code can run an x86 based host machine with the help of ISA emulation. With this approach, it is possible to run a large amount of legacy binary code written for various processors on any given new hardware host machine. Instruction set emulation leads a virtual ISAs created on any hardware machine. The basic emulation method is through code interpretation. An interpreter program interprets the source instructions to target instructions one by one. One source instruction may require tens or hundreds of native target instructions to perform its function. Obviously, this process is relatively slow. For better performance, the dynamic binary translation is desired. Now let us see about hardware abstraction level. The hardware level virtualization is performed right on the top of the bare hardware. The idea is to virtualize a computer's resources such as its processors, memory, and I/O devices. The intention is to upgrade the hardware utilization rate by multiple users concurrently. The operating system level. This refers to an abstraction layer between traditional OS and user applications. The OS level virtualization creates the isolated containers on a single physical server and the OS instances to utilize the hardware and software in data centers. The containers behave like real servers. The OS level virtualization is commonly used in creating the virtual hosting environments to allocate the hardware resources among a large number of mutually distrusting users. It is also used to a lesser extent in consolidating server hardware by moving services on separate hosts into containers or VMs on one server. Now let us see about library support level. Most applications use APIs exported by the user level libraries rather than using lengthy system calls by the OS. Since most systems provide well documented APIs such as an interface becomes another candidate for virtualization. Virtualization with library interfaces is possible by controlling the communication link between the applications and the rest of the systems through API hooks. The software tool Wine has implemented this approach to support Windows applications on top of the Unix hosts. Now let us see about user application level. The virtualization at the application level virtualizes an application as a virtual machine. On a traditional OS, an application often runs as a process. Therefore, the application level virtualization is also known as process level virtualization. The most popular approach is to deploy high level language, that is HLL VMs. Thank you.